Lots to cover. You'll need your calculators, by the way, so if you want to get those out now, just leave them on your desk. That would be awesome. So pretty much everything that we do in semester one is based around two-dimensional figures, so things that you can draw on your paper. It's not till we get to second semester that we start looking at three-dimensional figures. And so we have a lot of new terms to cover today. So let's start with this one, polygons. On the left are polygons. On the right are things that are not polygons. So the question for you today is, what's a polygon? Let's write some definitions. Just go ahead, raise your hand. Yeah, go ahead.
All sides of a polygon are connected.
I'm sorry, what?
All sides of a polygon.
All the sides of that polygon up in the upper right are connected.
A polygon is a closed figure with no curved lines.
A closed figure with no curved lines. What do you think?
Or 9 lines that cross.
Not closed. Good. Curved lines. Good. How about that guy? That's a closed figure with no curved lines.
That don't intersect.
These two segments intersect. Feel free to help her out.
There's no like continuation of the intersection.
There's no continuation of the intersection. What does that mean?
Because like in the two like triangles on top of each other, like the intersection continues, so like it wouldn't be a polygon because it goes like that.
That's not horrible, but is there a cleaner way that we can say that? Want some help?
Yeah.
All right, let's look at these two segments here. Where do these two segments intersect? Yeah, here, I know that, but I mean, give me more than just there. It's Matt, right?
Yeah.
Yeah.
They at the vertex or something.
You're putting the cart before the horse. Not the just think about this segment. Where does that segment intersect with that segment? At that point,
Yeah.
which is specific to this segment. How?
It's what's the name of the line?
Mhm.
I don't know.
Never mind.
You list out.
Well, I was gonna say like the intersection point, but I
Yeah. And what's special about that intersection point?
It's perfectly percent.
Okay, so think about that for a second. We're almost there. And think about these two segments. This segment and that segment. Where do they intersect?
In the middle. What would they intersect? Here.
How does one write that for a definition? Are we gonna have to draw this every time we talk about the definition of polygon?
Where the two lines meet.
Segments.
The 2 line segments meet.
Uh-huh. Correct. So what's the difference between where these 2 line segments meet versus where those 2 line segments meet?
Those.
Fair?
Well, on the not polygon, they have like two line segments, I think, and that has like 1 point in it.
Okay, not bad.
Those create vertical angles in those two.
Well, I don't know if we want to go there. Because then our definition of a polygon is dependent on whether or not the person reading it knows what a vertical angle is. And I know all you guys do. What if you know?
Is it the polygons lines like meet at the end point?
Bingo. Okay? So these segments all intersect at endpoints. No other points of intersection like you said, Sarah. These, however, intersect not only at the endpoints but also somewhere on the segment. So if we take all that, throw it in the pot, and stir it up, what do we have for a definition of a polygon? Tom.
A shape that is closed.
Good, I like closed. Hold on, before we go any further, are we okay with shape or, I forgot your name, I'm sorry.
Alyssa.
Alyssa. Are we okay with shape or do you want figure?
Figure.
They like figure better, sorry. A figure that's closed, I like that.
Figure that's closed with no curved edges.
Good.
Only has endpoints for the lines.
Clean that up a little bit, Alyssa.
A closed figure with no curved edges that only intersect the endpoints.
Okay, but almost there. But what is only intersecting at
sides.
endpoints? The sides, good, okay. So say it again for everybody to write down, that is perfect, go ahead.
Closed figure with no curved edges that the sides only intersect at endpoints.
Bingo, got that? Can you hear her, by the way?
Yeah.
Good. Question?
Can you repeat that?
Certainly. Can you repeat that?
A closed figure with no curved edges and the sides only intersect at endpoints.
Awesome.
And it's not round.
She said no curved sides.
No curve.
It's okay.
Okay.
So talking about polygons then, because it's closed, we have a definite interior and exterior. The segments that make up the polygon are called sides, and then Matt used a term for the corners. What are those corners called?
Vertex.
Vertex, right. You've got one of them, you got a vertex, you got more than one, they're vertices. Okay, we good? Nice job. Okay, well, there's a lot of different things about polygons we're going to talk about. The first is convex versus concave. I'm going to show you a fancy schmancy mathematical definition, but then I'll show you a practical way to remember which is which. Okay, so convex. No line containing a side passes through any part of the interior of the polygon. Concave, a line containing a side of the polygon passes through the interior of the polygon. There is a non-convex. Okay, in other words, if I take any side of this is a convex polygon. Okay, we'll deal mainly with convex polygons. If I extend any one of these segments into lines, it doesn't pass through the yellow part. Over here is a concave polygon. If I extend one of the sides into a line, it passes through the interior blue part. Okay. This is all nice and peachy keen, but realistically you're going to remember this is concave because it's caved in on itself. A little bit easier. And again, most of the time we'll deal with convex, but occasionally we'll pop up with a concave. And just to confuse matters worse, sometimes concave is also called non-convex. But for some reason, convex is never called non-concave. I don't know why.
Would you accept non-convex on a test or quiz?
Sure. Same thing. But again, I like to use concave because I can remember it caves in on itself. Okay, we good? So you can write all this gunk down, but you don't really need it if you can just identify convex and concave polygons. Okay, you're responsible for knowing the names of the polygons 1 through 12. So we're going to start with the thing in the upper left-hand corner, which is that light purple color. What is that called, Simon?
Triangle.
It is a triangle, very good. In the upper right corner in the bright green, what is that called? Madeline? Want some help? Anybody else? No, we've heard enough from you. Let's get some other people involved. Bree, what's that thing called?
Quadrilateral.
Beautiful. Quadrilateral. Quad meaning 4, lateral meaning sides, 4 sides. Which, strangely enough, a triangle is tri meaning 3, angle meaning angle. So the triangle is named by the angles, but the quadrilateral is named by the sides. Moving down to the puke green thing, what's that called? Go ahead. Beautiful. Redemption there. Pentagon. P-E-N-T-A-G-O-N. Penta, 5, gon, sides. The white thing in the lower left is what, Julia? Any idea? What's a what's it called when a witch puts an evil curse on you? Say again?
Hexagon.
It's a hexagon, correct? H-E-X-A-G-O-N. Where do we go to next? I think it's the gray thing. 1, 2, 3, 4, 5. Yeah, the gray thing with 7 sides. 2 answers. Can you get them both, Alyssa? Septagon is one. Anybody know the other one? You can also use heptagon for 7. Then, of course, we all know what the red thing is called. Don't we?
Yeah.
Octagon. Octagon. Now we go to the big yellow thing in the center. Go ahead. Nonagon, Nonagon, 9 sides. Nonagon, not ninogon. And then the purple thing, the bottom right. Matt, are you raising your hand?
Yeah.
What do you got?
Is it a octagon or something?
Nope. Macho.
Decagon?
Decagon, correct, Deca 10. Now, we could spend time learning how to name any sided polygon using the Greek roots that we're using now, but we're just going to stop at 12. Any idea what an 11-sided is called? Okay, I wouldn't expect you to know this, but it's an undecagon, U-N-D-E-C-A-G-O-N. Un 1, deca 10, 1 plus 10, 11. Doing some pattern recognition, what would 12 be? Beautiful, dodecagon, D-O-D-E-C-A-G-O-N. So we could keep going. Tridecagon, quaddecagon, pentadecagon, and well, we're not going to spend the time. Anything over 12, we're just going to call it by the number dash gon. So if I've got 37 sides, it would be a 37 gon. We're going to take the easy way out instead of all these weird roots. Okay, but you need to know 1 through 12. The thing I would warn you about is that that green thing up on top is a quadrilateral. It's not a rectangle, a square, a trapezoid, or any of those other 4-sided things that we'll talk about later. It's just a quadrilateral.
Wait, what did you say 11 and 12?
Rhombus.
11, undecagon,
Uh-huh,
and 12 is dodecagon.
okay.
Question? 10, decagon. Okay, got all those? Beautiful. All right, next on the agenda. A couple different words for you there. Equilateral. What does equilateral mean? Right, break it down. Equa means equal, lateral means side. All the sides are equal. Following that, what would equiangular mean?
All the angles are equal?
All the angles are equal. If it's both equilateral and equiangular, like it says up there, it's something we call a regular polygon. Okay, so 3 terms there you need to know. Equilateral, equiangular, and regular. You can have polygons that are equilateral, but not equiangular. You can have polygons that are equiangular, but not equilateral. And then you can have polygons that are regular polygons that are both. So most of the stereotypical shapes that you know are going to be regular polygons. A stop sign is a regular octagon. A square is a regular quadrilateral. And now we're going to put the cart before the horse again and talk about some things that we haven't really defined. So we're going to do some perimeter and area of shapes, which we haven't officially defined a triangle other than it's a 3-sided polygon and haven't talked about it that much, but we'll be okay. So here's a polygon, a triangle in particular. I labeled the 3 sides C, B, and D, and then I got this thing called H. What's perimeter mean?
It's the measure of the lines on the outside of the triangle.
The segments on the outside triangle. Good. So in other words, C plus D plus B. Okay. Area is the amount of surface inside the polygon. So perimeter is really simple. Add up the 3 sides. That's true of any figure. Doesn't matter what it is. Just add up the 3 sides. Area, however, you all know is 1/2 base times height. Or if you prefer base times height over 2. Make sure that you remember that height has to be perpendicular to the base. C is not a height, D is not a height, H is the height. In other words, if you were standing on top of the mountain, it would be the distance that a ball would drop if you dropped it straight down. You know all this, right?
Yeah.
Good. Again, using terms we haven't defined yet, a square, you should pretty much have a good idea what a square is. It has 4 equal sides and 4 equal angles. The perimeter there is, again, add up all 4 sides, but since the sides are all the same, you could just do 4 times s. And then the area is s squared. Take one of the sides and multiply it by itself. S times s, or s squared. And again, you knew that already, right? Good. Okay. Now we got a rectangle. How's a rectangle differ from a square?
Not all sides are equal.
Not all sides are equal. Good. However, there are 2 pairs of equal sides, right? So Simon, what's the perimeter of that rectangle?
It's L plus L plus W plus W.
Is there a fancier way you could write that?
Yes. I don't know.
But you don't want to tell us? Is it a secret?
No.
Jolita, right?
2L plus 2W.
Good. 2L plus 2W. Either is correct, it doesn't matter. And then the area is length times width, or base times height, depending on how you want to phrase that. It's the same thing. Okay, doing good so far? Not a big deal there? Now the circle. Okay, so before we start talking about the circle, we need to define the circle, okay? Because I don't know, have you ever defined a circle? You all know what a circle is, right?
Yeah.
Right?
Just like you knew what a triangle is. A triangle is a 3-sided polygon. A square is a 4-sided polygon with all this other stuff. What is a circle? Go, give it a shot.
Isn't it like a figure
Good start.
that from the middle? What's the middle part?
Center,
Center?
right?
It's like the same distance all around.
Perfect. Great. Can you clean it up a little bit? It's a set of points that are the same distance away from a given point called the center. Good. Circles have centers, not midpoints. Okay. So that thing in the center is the center. The center, however, is not part of the circle. So looking at that picture up there, I've got some red stuff, some brown stuff, and some blue stuff. The circle is only the blue stuff. It's like a hula hoop. You guys do know what a hula hoop is, right? Okay, I wasn't sure. Didn't know if those had fallen out of fashion. Can anybody hula hoop?
Nope.
Beautiful. I have never been able to learn.
You fool.
Not that I practice a lot either. What's the R? It's a radius, which means what? 2. Where on the circle? Does it matter? Good. Okay, distance from the center to any point on the circle. What? Let's stay with you, Colin. Right? What's D? Nope. Nope. Grace, right?
Yeah.
Go.
Diameter.
It's a diameter. What's a diameter, Grace?
It's the distance between like the farthest point up here and the farthest point up here.
If I just had a circle, how would I draw a diameter in? Because I understand what you're saying, but we want to be able to clean that up a little bit so that I don't make the mistake of picking a point here and a point over here. That wouldn't be a diameter, right? I want that biggest distance. So how do I guarantee that the segment that I draw is a diameter and or the biggest distance?
So it's like the farthest point from, so it's the point farthest from the other point.
Good. How do you find that? Anybody else? Matt, you're full of answers today. I
Can
like
we do
it.
R squared?
Oh no, that comes later. Don't start throwing calculations at me. I'm not ready for that yet. Time.
Don't you have to go through the center?
Bingo. Okay, it goes through the center. So if I just give you a circle and I want you to draw the diameter, to make sure that you have a diameter, it has to pass through the circle. Okay. Now, mathematically, Matt, what's the relationship between R and D?
If you do R squared, you get D.
Not R squared.
2R.
2R, right. D is twice as long as R, or R is half of D. Okay, a lot going on there. Again, remember the brown is not part of the circle. That's called a circle interior. But when we get going and things get lazy, we will just call that a circle anyways, but, okay. Circumference. What is circumference? Yeah.
It's the area around the circle.
Oh, careful what words you're using.
Distance. around
There
the
you go. It's a distance around the circle. So why isn't that a perimeter, Jalen?
Because perimeter is for sides and the circle only has one side.
Ooh, now you've opened a whole new can of worms. So she just said a circle has only one side. Do we agree?
Yeah.
It has no s-
Somebody want to counter?
Doesn't it have infinity?
Oh, now it has an infinite number of sides.
Wait.
Oh. You want to jump on that bandwagon?
No, I think it has no sides.
Nope. Oh, you're making things more difficult. Now we have three choices. Zero sides, one side, infinite number of sides.
0.
sides aren't even real.
Sides aren't even real.
4.
I don't want to go down that rabbit hole.
How can sides be real for I?
Okay, so let's suppose I took a square and I added a side, I'd get a pentagon, and then I add a side and I get a hexagon. As I continue to increase the number of sides, do we all agree that it would eventually approach something that looks like a circle?
Yeah.
So we can see how the answer of infinity would apply, right? All right, what about the idea of it having 0 sides? Well, why does it have 0 sides? Because this is a curved surface. So it would have 0 sides because there's no sides there to count. You could also see where it would have only one side because it's right there in blue. Which one is it?
It's all of them.
All of them. Wow, that's very
All
Schrodinger
real
of you.
solutions.
Infinite.
Is that what you want to go with? There's really no wrong answer here. It's just how you want to visualize the circle. The point being, let's go back to your discussion. Whether it's 0, 1, or infinite, it's not a polygon. Are we all in agreement there?
Yeah.
Okay. You could argue that if it's infinity, it's a polygon with infinite number of sides, but we don't want to go down there. Just forget about it. So it's not a polygon, and since it's not a polygon, it can't have a perimeter because perimeters apply to polygons. So therefore, this is a circle, which has a circumference. Same idea as the perimeter, but we don't have sides to add up, so we have to come up with another formula. What's this guy right here? What is pi?
3.14.
Okay, bonus question, where does it come from? Other than the button on your calculator or some number that you probably in grammar school, somebody made you memorize as many digits as possible of pi for no purpose other than to show how good your memory is.
Radius.
No, behind you. Tell me your name again.
Kira,
Kira.
Is it from, I think it was the Grecians, is that where it was from, when they were trying to find, there was like a song about it that we learned in elementary school, but I can't remember how it went.
Oh, that would be so awesome if you could remember the song. If you did remember the song, you wouldn't even sing it, would you? No, okay.
I would say it.
Okay, so some people say, well, pi comes from the circumference and the area of a circle. But that's not right. That's going backwards. Okay, so they discovered pi first, then they came up with these formulas. Now, pi very simple, go way back 300, 400 BC. They didn't have paper, so these guys are drawing in sand. And they realized that if they drew a circle and they measured the diameter, that if they took the distance around the circle and divided it by the diameter, they kept getting the same number over and over again. So then they made the circles bigger and smaller, but they found regardless of the size of the circle, if you take the circumference and divide it by the diameter, you get this magic number pi. What's significant about the number pi?
It's never ending.
Good, and?
It never repeats.
Good, never ending, never repeats. For our purposes, when we're doing calculations with pi, you're going to use the pi button on your calculator. So find it on your calculator, make sure you see it. Don't use 3.14. Don't use 10 digits that you memorized in grammar school. Use the pi button. Everybody got it? It's over on the right-hand side of the calculator?
Oh, yeah.
All right, beautiful. Either one of these is good to go. Circumference is 2 pi r or circumference is d pi. Area, pi r squared. People always get this confused. Remember that area is square units, so you're going to square the radius. When you're doing circle calculations, there's two types of answers. There's an exact answer and there's an approximate answer. Okay, so let's suppose in this problem here, I know that the radius is 4. And I want to know the circumference in the area of that circle. First habit you have to get into is writing the formula. So I'm going to use circumference equals 2 pi r. Blank formula, no numbers plugged in. What that's doing is telling me I know what formula I'm using and I'm going from there. Okay, this is considered showing work. Now plug in what I know. I know that the radius is 4 and therefore I get 8 pi. This is an exact answer. If you leave it in terms of pi, that's an exact answer. However, I may also ask you for an approximate answer, which would then be 8 times pi on your calculator, which would be
25.1.
25 point, we'll go 2 decimal places as our standard.
25.13.
13. Did you round that correctly?
2.
It's
No,
one
it's
three.
one
It's
three.
one
Yeah,
it's
three.
1 3 2. So it's
1
1
3.
3.
1 3.
Yeah.
1 3. 1 3. Units. I didn't give you units, so if you don't know the units, you use units. If I give you units, then inches, feet, miles, yards, hands, whatever. Okay? So the important thing there is to remember the difference between an exact answer and an approximate answer. Approximate answer would be decimal, exact has pi.
Isn't the approximate answer units squared or is it just units?
No, because that's just circumference is distance.
Oh yeah.
Now, if we want to do area, so again, start with the blank formula, pi r squared, plug in what we know, and we get 16 pi units squared. Those are square units because it's area. There's the exact answer. If we want the approximate answer, we would multiply that out and get something like 50 point, 50.27 units squared. Okay. Any problems? Awesome. Now we're going to do a calculation. So you got a dog. Question?
Why is the squared still there, like when you're at the area? Why is it like 2 squared?
Because it's unit squared. So if you're talking about feet, it would be feet squared. Those are our units, not the value of the answer. Question?
Is that your dog?
No, I don't have a dog. I have children.
Better to get your children a dog.
Because that
Great question. My son's been asking for a dog since he was 6.
my mom got me a dog. I was never I've never happy with her ever again.
You were never happy?
No, that dog ruined my whole entire life.
Why?
Why?
Cause my
Hold on, is this going to turn into like a therapy session?
No.
Do you want a couch to lay down on?
There
I'm
you
good, I have it
Mr.
once.
R.
Wait, how
Why do you hate your dog?
I don't hate my dog. My dog is just really annoying.
Why is it annoying?
So are my children.
Okay, I'm not paying you to be my therapist. I don't think my therapist wants to pay you.
I'm
And
doing it
how
for
does it
free.
make you feel?
No, we don't care. All right, so we've got a dog. We want to build a dog run in the backyard. You know what a dog run is? Okay, it's a rectangular fenced-in area where you put your dog in, and then the dog can run. We have 100 feet of fencing. Okay. What we want to do is, we like our dog, unlike some people, and we'd like the dog to have a maximum amount of area to run in. So we put your hand down. I didn't ask you a question yet.
The let it run in the street.
So here's my dog run.
What's a dog run? It's not a very big
It's like a
dog.
type of like thing. It's like a fenced out area a dog can run in.
It's a rectangular fenced-in area that you put the dog in, and then they can run. Hence the term, dog run.
No, it's a sport where you take the dog, tie it to your leg, and you let him drag you.
Is everybody else with me? You've heard this term.
I've
All right,
never heard of it, but I
You said that,
understand what you
All right.
mean.
Yeah, I get what
So,
my backyard is this.
we're gonna do this mathematically. We're not gonna use guess and check, because guess and check is seldomly, if ever, a valid method. So we're gonna create a mathematical problem, or I should say equation, and work with that equation. Okay, which means I need a variable. So I'm gonna call this x. It's a rectangle, so if that's x, how long is that? Very good. Now we need to find the other sides. And so finding the other sides can be a little bit tricky. You have one of two approaches. You can muscle it out and figure it out, which we'll do in a second, or we can create another variable. I'm hesitant to create another variable, but we can. Okay, so if we create another variable, we'll do that in red. I'd call this y, which is not good because 2 variables means I need 2 equations, and I'm trying to avoid that. But one equation I know is that x plus y plus y equals
100.
100. Okay? So then I do a little bit of math. I don't want the y's there. I want to get rid of the y's. So if I simplify this, I get 2x plus 2y is equal to 100, which means divide everything by 2, x plus y equals 50. So therefore, y is equal to 50 minus x. We could have figured that out if we just got after it and spent 10 minutes trying to figure out what that other side would be, but we didn't. We got that. So I'm going to come over here, get rid of the y's. I'm done with the y's now, and write it in terms of x, back to blue. Okay, so this is 50 minus x, and this is 50 minus x. Okay, so we got our setup now. We good? Okay. Now, I want to maximize the area, so I need an equation for the area of this rectangle. Rectangle is length times width, so what's the length of that rectangle?
Well,
X, and what's the width? 50 minus x. Okay, so that gives me negative x squared plus 50x. Did a little bit of algebra there. There's my equation. And I'm going to get all fancy in my pantsies here and write it this way. Woo! That's the area in terms of x. And there's our equation. Do you know anything about that equation? No? Okay, Natalie? Don't be bashful. The worst that could happen is you're wrong, and we can just point and laugh at you.
Never mind.
Okay? Don't know? Simon?
X side.
Nope, we're going to leave it just like, oh, you know what? I forgot something here. That's an x there. Sorry.
Oh.
Forgot that x. I didn't distribute it properly. Sarah? We could, but that's not going to get us where we need to go. We'd like to know what that looks like, right? Because we want to be able to find out the maximum area. So I could start plugging in numbers. Okay, so let's, for instance, say, let's get this out of the way. Let's suppose you didn't like your dog. Just for discussion purposes. You decide to create a dog run like this.
Okay, that's like.
Which basically you put your dog in, he runs, and then has to moonwalk all the way back, and then run. And so, and we'll pretend your dog isn't this big, but we'll say that you got a small little yippy dog, and you're going to put it in a pen that's 1 foot wide.
Jesus Christ, that's a little much.
I want to go on record as saying I don't recommend this. It's kind of sick and twisted, but we're illustrating a problem here. If that's 1, how long's the dog run?
44.
98.
Oh,
95.
or 48. No,
44.
49.
98.
49.
44 feet.
49.
48.
49.
38.
49. 49. 49.
I don't believe in science.
Yes.
Oh.
Yes, I was right.
Why?
Oh, because it's
Because 19 divided by 2.
Okay? So the dog can run for 49 feet, then has to back up 49 feet, then run again. Okay? Again, not what I would recommend. So if we decide to be a little bit more humane, we could, oh, I don't know, make it 2 feet. And so if it's 2 feet, the dog probably still can't turn around, but he's got a little bit of shoulder room and probably wouldn't rip his fur off on the fence when he runs by. How long would that dog run be?
48.
Okay. Now, we could sit here all day and by the way, area of this thing? 49, area of this thing?
40.
No.
96. 96.
96. So you see the area is going up. If we continue to shrink the pen, or the dog run I should say, it's going to get taller, and eventually we're going to find that maximum area. But again, that's guess and check, and we don't want to do guess and check, so now we're going to use the calculator. So we need to remember that formula. You got that written down, right? Negative x squared plus 50x. Now we're going to go over to the calculator. I got to do this first. Here, turn that off. Do a little bit of graphing here. Clear that. Okay, so I would like to get a picture of what that graph looks like. So I'm going to go to the y equals button, which is in the upper left-hand corner, hit y equals, and hopefully you have nothing in there. If you have anything in there, clear it out. And I'm going to put in the equation that we generated, which is negative x. There's a button up here that you can use. You don't have to use the x every time. You can use that as x squared minus plus plus 50x. Okay. Everybody with me so far? Lose anybody? No? We're good? All right. Now, the middle button up on the top is zoom. So hit zoom, and we're going to go with a zoom standard 6. And we see nothing. Why do we see nothing? Because this only graphs from 0 out to about 10. So we need to talk about what are my possibilities for the dog run. So what's the smallest value we could make x?
1.
49.
Let's suppose we're even more sick and twisted.
0.01.
0.
0.0, well, we could make it 0. So 0 is our bottom limit. So we're going to start at 0. What's the biggest I can make x? 100? 100. Can I have a pen that's 1 by 100? 50. Good. Okay. So I'm going to change my window, and the window button is, I can't see it. Is it that one? Yeah, the second one in. I should know that. I'm going to change x min to 0 because we can't have a negative distance. The dog would pop into another dimension. We want the max to be 50. Now, what about the y value? Well, y in this case represents area. Can we have a negative area?
No.
No, not in this universe. So that should be 0. 0? What's the maximum area? Well, we got 49, we got 98. This is just a guess and check, even though I said not to guess and check, but what should we put in for the maximum area? It's better to go too high than too low. Is 100 reasonable? No. Is 2,000 too much? Okay, let's do 2,000 then. We can always go back and change it. Okay, so we changed the window settings. Now, instead of going back to zoom, just hit the graph button in the upper right-hand corner, and we'll get a picture of our dog pen. How good was the 2,000?
Pretty good.
Not real good. No, we could have done better. Okay, so on the far left-hand side, we've got the real sick and twisted skinny dog pen. As we move to the right, we're increasing the width, which means we're also giving the dog more area. Then at the top of that thing, do anybody know what that thing's called, by the way? What shape that's called? It's a parabola. Very good. At the top of that is the maximum area, and then as we go to the other side, we start to shrink the dog run the other way. So how do I find that point? Well, it's pretty easy to do. You'll see above the trace button, there's the word calc. So go second, calc. Which one of those do you think we want? Maximum, number 4. Okay, so now you got to understand the syntax, meaning how do you do this? I'm sure that that's the maximum there, but it's asking me for the left bound, which means move a couple units to the left. Make sure you're to the left of what we're looking for. If you're not sure, move over a little bit more. You can't go too far to the left. Hit enter. Now it's going to ask you for a right bound, so you got to go to the right of what we're looking for. I went a little too far. Okay, we could be doing this the rest of the period. Stop, please. Oh boy. Coming back.
Like the dog.
I wouldn't have gone that far if I were you. I really screwed this up. Sorry, itchy trigger
I think
finger.
the dog.
Lots of times.
I think the dog left the pen.
Great idea.
Space.
Ah, good, we're in the pot. No, stop!
Space.
Yeah, I think the dog took off and flew.
Oh, you gotta be kidding. So hopefully you didn't do what I did, you just bop to the right a little bit, then hit enter, it'll ask you for guess, it doesn't matter, just hit enter again.
Oh, there it goes.
Come on, stop, 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 stop,
We jump and
stop! Oh. Alright, anyways,
Click 5 times, you have to believe.
below the graph, down here, it should tell you then what the maximum is. What's x?
600.
No, what's x, not y?
25.
25, good. So that tells us how big we want to make the pen. Then the y value represents the area. All right, I'm a glutton for punishment. I'm going to try it once more. 1, 2, 3, 4, 5.
It's 8 on the rib.
Click the other way.
Press
Click the
the
other way.
middle
Click the other way. Click the other way.
I'm done, I'm done, I'm done.
While it's
I'm done.
on the graph, you have to
Done.
click the other side.
If you guys weren't in here, I'd flip off the calculator. So, what does that mean? So we got an answer. We know the maximum area now. It's 25. What shape is the dog run?
It's still
It's
going.
still-
It's still
You
going.
have to click the opposite direction when it's in the right spot.
No way.
Yeah,
Here's how you solve the problem. Bingo.
Oh, that was
Done.
rude.
Okay. So, we know then that the maximum area is 625 when one side of the dog pen is 25, which means what shape is it?
Square.
It's a square, correct. It's 25 by 25. What happens if we remove the restriction of it being a rectangle and or a square? How do you get the maximum area? Any guesses what shape it would be?
A circle.
Very good. Circle.
Dog, what do you think you're a dog?
So a lot of times what people do is instead of building a dog run in their backyard, which means buying fencing and figuring out how big to make it and putting that, they'll just drive a stake into the ground and chain the dog to a stake, because then the dog can run in a circle and it has the maximum amount of area.
I just let my dog run around my backyard.
Well, yeah, if your backyard's fenced in. If your backyard's not fenced
It is,
in,
it
then
is, but there's one area that isn't, so she likes to run away a lot.
He
I'm
doesn't-
sure,
he
I'm
doesn't
sure
mind
you
that.
don't encourage the dog running away at all.
No,
Ever.
like back
He does
before
not
Go,
mind
be
that.
free, don't come back.
Back when I could stand my dog, that's the reason I started like not like taking care of my dog, because she would just run away and my mom would be like, yeah, I'm too lazy. Go across the neighborhood and find the dog with no leash on running around in the streets. Like, okay, thanks.
Stop, you're gonna make me cry. It's such a sad story. I don't think we need to do this because I did an example earlier on the circle. Yeah?
Yeah.
Circumference 12 pi, area 36 pi. We're good? All right, last example. We can do a little bit of graphing. Okay? And so to graph that and calculate the area, you'll notice that there's something significant about these 3 points. The fact is that 2 of them are on the same y value. So you'll get a triangle that has a nice distance along the horizontal, and then the height is easy to calculate too. So if you graph that, it's not too bad to do. The other way is to, or what you're going to have to do is do a distance formula to find out some of the lengths. Sometimes you'll need to do distance formula, sometimes you can just count. So graph that bad boy, count what you need, calculate the area. Okay? Problems? We're all done. Okay. If you had trouble with that calculator problem, you need to be able to do that calculation. So you need to be able to come up with an equation for the area. You need to be able to put that area into the calculator. You need to be able to find the maximum of that equation. And some of that requires a little bit of thought. It's not just a plug and chug. We had to discuss what are my ranges of x values from 0 to 50. Let's